Welcome to Java Enterprise Edition channel. Thanks for joining me. Let's get started. Today we will explore how to set up a production grade MySQL cluster. Normally, when we set up the MySQL cluster with the big player, it is going to cost a lot of money. But today I'll show you how to achieve the same setup without spending a fortune. Let's get started. My name is Rajagopal Bhaskaran. I am a technical architect and I'll be your instructor for this session. First of all, why we need a MySQL cluster? It is required and essential for ensuring your database is always accessible, handling growing workloads, and protecting your data with a real-time replication. Let's talk about how much it's going to cost us in order to set up the MySQL cluster. We will be needing 4 Linux machines and 1 load balancer. All this machine has the configuration of 2 cores, 4 GB of RAM and 40 GB of SSD with 20 TB of traffic. So we'll set up 3 SQL nodes among different region, and then we set up SQL Manager, which is primarily responsible for replicating the data among all the SQL nodes. So this is going to cost us around like 20 euro, approximately $21, maybe $22. So that's about the overall cost involved in setting up the MySQL cluster. So this is a simple application architecture that I created for a demo purpose, right? So I have a Spring Boot application that I've created, which I'll show you later part of this session. And this application would talk to cloud-based software load balancer, which is sitting inside the Hetzner Cloud. And then this load balancer would distribute the request to all this node based on the algorithm that we defined at the load balancer level. We have a least connection, and then we have round robin algorithm. So we can choose any one of them in order to distribute the request to among all these nodes. So we will look at the application code and then how it works once we're done with the setting up the MySQL cluster. While setting up the MySQL cluster, we will be using Galera cluster, MariaDB, Hetzner, Cloudflare, and Ubuntu. As you see, Galera cluster will be used to set up the MySQL cluster. And then within the Galera cluster, we will be using MariaDB as our SQL server, and then create multiple SQL node, MariaDB SQL node. Obviously, Hetzner is the cloud provider, right? So we will be creating all our Ubuntu operating system and set up 3 SQL node. And also we will set up 1 Galera Manager, which is primarily responsible for replicating the data among all the SQL node. And then obviously Ubuntu is the operating system. And then we have Cloudflare. So where we will be setting up all the DNS for accessing the Galera Manager and accessing the MySQL load balancer through the DNS name. So we have sequence of steps to be followed in order to set up the high available cluster on the Hetzner server. So before even we start setting up the cluster, we need to create the VPC to isolate and then secure the machines so that it will not be accessible outside of the VPC. So first step will be to set up the VPC for our cluster. Second step would be to create 4 different Linux operating system under the VPC. As I said, we need 4 Linux server, one for Galera Manager, and then 3 machines for setting up the SQL node. If you look at the step 2 on MySQL node, I mentioned one node 1 with the public IP, and then second node with the private IP, and then third node also with the private IP. The reason why I have that, because we don't want to expose all the MySQL node outside of the VPC. For sometimes we need to access certain data from the internet. That's the reason why I am going to set up node number 1 with the public IP. But that can be turned off. Just for the demo purpose, I'll be setting up one public IP on one of the node and then keep the other node with the private IP. So any server that is sitting inside the VPC cannot be accessed except the one node which has the public IP. We'll discuss more in upcoming session. The next step is to install the Galera Manager. So we need to download the Galera Manager installation file from the official website, and then using the installer, we can able to set up the Galera Manager on the Linux machine. So in order to install the Galera Manager, what we have to do is we have to configure the DNS host name for Galera Manager. We have the host name called dbmgr.javaee.net is a host name for the Galera Manager. So using the host name, we need to install the Galera Manager, which is basically subdomain, right? So we need to install the Galera Manager subdomain, and then once we set up it, then we can able to access the Galera Manager through the subdomain. As we discussed before, we need to set up 2 different DNS name for SQL cluster. One for Galera Manager. So we will be setting up the Galera Manager with the host name of dbmgr.javaee.net. The second one would be for the load balancer. So we'll set up the load balancer with the host name of SQL LB, which is load balancer.javaee.net. DB Manager will be used, the DB Manager host will be used to access the Galera Manager. And then load balancer host name, which is SQL LB javaee.net, will be used to access the MySQL cluster. After setting the Galera Manager, we need to define the MySQL cluster. The MySQL cluster can be created through the Galera Manager interface itself. Once we're done with the creation of the cluster, then we need to install all these 3 nodes on the Galera Manager itself. So this is the high-level architecture for the MySQL clusters that we have been discussing, right? As I said, we'll be using the Cloudflare and Hetzner to set up the MySQL cluster. The left side, as you see, we have Cloudflare. We will be setting up these two DNS host name. One for accessing the Galera Manager, and then second one is accessing the load balancer. As I said, in order to set up the SQL cluster and set up respect to SQL node, we need to access the Galera Manager, and then the Galera Manager can be accessed through the host name. And then similarly, we have another host name, as we discussed, in order to access the load balancer. So we can access the load balancer using sql.lb.java.ee.net host name to access the load balancer, and then the load balancer will take care of distributing the requests to the respective node based on the algorithm that we define. So there are two different algorithms. One is round robin, and then the another one is with the less load. So we can configure either one of this algorithm at load balancer level in order to distribute the request to the SQL nodes. As you see, we have public IP through which we can able to access this load balancer through the host name, and then the load balancer distribute the request to these nodes through either public address or the private address. So typically how we set up, we define private IP for all the nodes, yeah, and then we also enable the public IP on one of the SQL node in order to access the SQL server from the internet. For some reason, if you want to validate, or someone needed to have a look at the database from through the internet, they can only do that if the node has the public IP address, right? So we can able to enable it and disable it on need basis. Just for the demo purpose, I'll be setting up the public IP and private IP on these SQL nodes. So this is how the overall architecture of the SQL server that we're going to set up. Now we are looking at the Hetzner Cloud dashboard, where we will be creating all the resources needed to set up the MySQL cluster. First thing is first, let's go and create the VPC. As I said, we are creating the VPC to put all our resources inside the VPC to protect all the resources that we create for the MySQL cluster. Okay, let's create the VPC. I'm gonna name the VPC as MySQL cluster net, yeah, and then I'm gonna leave everything as it is, and then not gonna touch any of this. So let's create. Now we have the VPC created, right? And we have a subnet created by default. Now it's time to go and create the server. So first, I'm going to create the server for Galera Manager, and then as soon as you try to click on the Add Manager button, we will end up in this page. So we have plenty of options, right? We have a different, the location where we can able to create the servers. I'm going to choose the Helsinki region, and then I'm going to select the Ubuntu 22, and then I'm going to be selecting the Intel architecture with 2 B cores with the 4 GB of RAM, and I'm gonna enable the public IP address, because we need the public IP address in order to configure the host name to access the Galera Manager through the host name. So we need for sure the public IP address for sure, and we can also attach the Galera Manager to the private network, but I'm not sure whether we really need the private IP address for the Galera Manager. For that reason, I'm just, I'm not selecting the private network. And then we have other option. We can able to add the volume and then firewall backup and things like that, but we are not going to do anything for now. Okay, I'm going to name this as like Galera Manager, and then I'm just going to create. So now that we have the Ubuntu server created for Galera Manager, I'm going to add 3 more server, right? It's going to be very quick. So, and for the first SQL node, I'm going to enable public IP address along with the private IP address as well, right? So, and we don't need any of this option. And then I'm going to name this as MySQL node 1, yeah, and then I'm going to create. So, and then the another one, same operating system, and then same server, enabling the private network, and then naming this one as 2, yeah. Similarly, the third one. So let me choose the different region. And then I'm selecting only the private network. Actually, I should have not selected the public address for the previous instance that we created, but that's okay, right? So I'm creating these 3. Okay, let's go back and then disable the public. So we have option to disable the public network, right? In order to do that, we need to shut down the machine. So I'm going to do that. So node 2 has the public address. If you look at this is the public address, right? I can able to disable, yeah. Now it's disabled. You don't see the public IP at all, right? Now I can turn the machine back on. So now we have all this machines created, 1 for Galera, 3 for SQL node, with 1 machine with public IP and private IP address, and then 2 nodes with only private IP address. So now that we created all this server that we needed, the second thing that we need to do is to set up the load balancer, right? Let's create the load balancer. So I'm going to create the load balancer on the same Helsinki region, and I'm going to choose the least option. This one going to cost us around like 5.3 euro, but we have other options as well. But the difference between these 3 options, if you look at this, right, for 5.39 euro, we can able to scale the basically we can able to scale the application with a 10,000 concurrent user, which is crazy. Just for 5.39 euro, this load balancer can able to handle 10,000 concurrent connection, which is huge, right? And then for $16, it is 20,000 concurrent user. With the $32, it is 40,000 concurrent connections, which is really huge, and then it's very cheaper for this price. And the Hetzner will take care of all the pains behind the scene. All we have to do is just set up and then choose the respective one. Boom, that's it, right? So at least for our demo purpose, I'm going to have the least one, which is going to cost us 5.39 euro, and I'm going to select the private network. But again, we don't really need the private network for the load balancer. I'm just choosing, right? And just I'm choosing it to have the private IP address for the load balancer as well. Yeah. So what we're actually going to do, we are using this load balancer for the SQL, right? To distribute the traffic to the SQL nodes, right? So we need to choose the TCP, not the HTTP, and then port going to be the 3306, and then the target also going to be 3306, right? And then we done that, and then from the algorithm perspective, as I said, we have two options. One is round robin, and second one is the least connections. Let's go ahead with the round robin, right? You guys can choose based on your need, but I'm at least choosing the round robin as an algorithm for the load balancer. So I'm going to name this as SQL load balancer, yeah, and I want to make sure that I'm not missing anything. All right, let's create it. Now that we have the load balancer, right? So what we have to do, we have to add all the nodes under the SQL load balancer. That is something that we'll do once we set up all the the SQL cluster first. That's all for now. Let's see in the next. Now it's time to set up the host name for Galera Manager and SQL load balancer. So right now I'm looking at the Cloudflare dashboard where I have the domain name registered. So I have the domain java.ee.net registered with the Cloudflare. So in order to set up the host name for Galera Manager and the SQL load balancer, we need to go to the DNS section, and then we need to click on the add record, and then we need to create SQL LB, right, which is SQL load balancer, and I need to put the IP address here, which is which can be found in the load balancer section. So this is the public IP address, right? I'm just going to copy this, and then going to go back here and put it here, right? And then save record. So now that I've done with the SQL load balancer, and I'm going to create the record for Galera DB Manager. So we created the host name as DBMGR, and so this DBMGR is a subdomain, which is host name on top of the java.ee.net domain, right? So and this records the IP address. So Galera Manager, we created an instance for Galera Manager and enabled the public IP address, right? This is the public IP address for the Galera Manager. I'm just copying this and then going back and putting it here. Yeah. So now that we have the host name created for both the DB manager and then SQL load balancer, so we can able to call dbmanager.java.ee.net and then SQLDB SQLLB.java.ee.net on the host names, right? These are the host names that we can use. Okay, so now we're done with the host name. It's time to go and set up the Galera Manager. Now we need to set up the Galera cluster. The first thing that we need to do is to download the Galera Manager from the official website. So this is the official website, that is galeracluster.com, and we have this Galera -manager URL. If you go there, we can able to see there is a link for downloading the Galera Manager. So I'm going to click that. So as soon as I click on this link, the Galera Manager installer automatically downloaded, because I given the email address before, so it is in the cache. So that's why it never asked me to give my information. So typically we end up a page where we need to give our first name, last name, and the email address. As soon as we submit the information, it will automatically download it, as you guys just see, right? Using this installer, we're gonna set up the Galera Manager. Now it's time to install the Galera Manager on the Ubuntu server. Let me copy the IP address and then access the server through the SSH client. So now we need to copy the Galera Manager to the server. So I'm doing that. It's been copied over to the server, and let's check whether the installer is uploaded. Yeah, now we see the installer here, and we need to give the permission before we start installing. So let me give that. And then start the installer. So we need to give the parameter as install to begin the installation. Yeah, doing that, and then we need to agree on the license agreements. I'm gonna say yes, and then let's keep the repository as default, and then keep the Galera Manager username as admin, then password, now we have to give the host name of the Galera Manager that we have configured in the Cloudflare, which is dbmgr.javaee.net. So now it is asking whether we need to enable the HTTPS or not. Here we can either say yes or no. If we say yes, then this process will install the free SSL certificate on the server, right? And if you do that, then again we need to make some changes on the Cloudflare on the certificate configuration. Yeah, but that is a little bit complex. For now, I'm not going to install the certificate on the server, and I'm letting Cloudflare to take care of the the SSL. Okay, so let's choose no. Now the installer installing all the necessity packages, and it's going to take like 2 to 3 minutes. I'm going to pause the video and come back. Now the installation has been completed. Let me grab the URL of the Galera Manager, and let me see. Now that we have the Galera Manager installed on the Ubuntu server, and let's try to access the manager. Yep, so now we successfully install the Galera Manager, and then currently we are looking at the Galera Manager dashboard. The next step, now let's set up the SQL cluster. So as soon as click on the add cluster, we have a couple of options. So we can set up the manage cluster on the DigitalOcean and AWS. Since we already created the server, so I'm going to choose the user provided host. So as soon as we click select the option, we would end up landing this page where we need to give the name for the cluster. Let me give the name as Java EE SQL cluster, and then we need to choose the specific DB engine. So I'm going to choose the MariaDB 10.11, and we have a couple of other options, but I'm going to choose this one. And then since we have the Ubuntu 22 created, I'm going to choose this one. And then if you see the other option, we have two more options. One is custom DB engine configuration, and the second one is the firewall. So certain port has to be opened in order for Galera Manager to access the node. So these are all the default ports that are required in order for Galera Manager to talk to the SQL node and for exchanging the data, right? So I'm going to keep as it is. And then the other option that we see here is a custom DB configuration. So basically, this is something that we need to look into when we need to make some changes, and when we need to make set certain performance related configuration and the MariaDB level, right? So, but at least for this video, I'm not gonna set any of this. I'm gonna leave it blank. We'll come back later when we need to improve the performance of the MySQL server. Okay, so let's not do anything here, and then I'm creating it. So now the cluster being created. It's gonna take maybe a couple of seconds. Yeah, so the cluster has been created. Now we have the SSH key, right? So this key has to be added into the SQL node in order for Galera Manager to access those nodes and install the all the necessity software like MariaDB, right? I'm gonna copy this. I'm gonna keep it in the notepad. Yeah. So we need to add all this key into all the SQL nodes. So I'm gonna do that, and let's finish this setup. And now we have the the MySQL cluster created, but we need to add a node in order to actually create the database, right? So we're going to be looking at in the next video. Now it's time to add the public key into all this node that we created for Galera Manager to install the MariaDB server in each and every node, right? A quick note, I have enabled the public IP for all the node because we need to add the public key to all these nodes, but we can add the public key through the console, but it has some restriction on the the amount of data, the character that can be pasted in, right? So that's why I have enabled the public key so that we can we enabled the public IP so that we can able to add the a public key of Galera Manager in all the node. Okay, so it's just to it's just a quick note for you guys. Okay, so now we are going to add the public key in all these three nodes by accessing through the public IP. Okay. Yep. Let's do that for SQL node. I'm copying the public IP. It's logged in. I need to access the console, and then I need to so this is the public key generated by the Galera Manager, as you see in the previous section, right? So I copied that, and then so we need to execute these two commands. So basically I copied this public key in here. So I'm going to copy this, and I'm going to execute this command as well. So now the Galera Manager can able to access the node 1, yeah. And so I'm going to come back and then add the the public key to other two nodes. But now let's go and check whether Galera Manager can able to access the SQL node 1 from the Galera Manager. Add the node. So how do we do that? Let's go here and we click on the Java EE SQL cluster. We have an option to add the node. I'm going to add the node by clicking on Add Node button. When we do that, we have option here where we can specify the name of the node, and then it is as we know that Ubuntu 22 is the version that we choose, and let's keep this segment as 1, and then we have the port 22 by default, and we need to give the address of the server, right? So here I'm not giving the public IP address, because since the Galera Manager within the server this one can able to access any server within the network, right? So for that reason I'm not giving the public address, and so let's check whether Galera Manager can able to talk to the node through the private address. How do I do that? By simply clicking on the check access button here. Seems like Galera Manager unable to access the node, and let's check why. That is because the Galera Manager is not part of the network, the VPC, right? So let's go ahead and then put this Galera Manager into the network. So how do I do that? I can come to the network tab section on the Galera Manager server, and then we have the private network, right, option, and we have two options, create or attach. Since we already have one, we're going to attach this server into the VPC that we created. So we have this one, MySQL cluster node that we created earlier. So I'm going to attach this server to this network. Once it's done, Then you see the private IP address has been assigned to the Galera Manager, right? Now let's go back and check whether the Galera Manager can able to access this server. Now, if you see, now it can able to access, right? So the next step would be to deploy the MariaDB on the node 1, right? Let's do that. So as soon as we click on the button, Galera Manager started installing the MariaDB on the node 1. It's going to take some time. I'm going to pause and come back once it's done. Now the MariaDB has been successfully installed on the node 1. I am going to do the same thing for other server as well. So how do I do that? Again, just so in order to add another node, click on the three dots here and click on node, and I'm going to name this one as MySQL node 2, right? And then everything same, and the IP address of the node 2 is 10.0.0.3. I'm just copying this and pasting it here, and check whether it has access. Now it says some issue. Let me see. For some reason, maybe the public key is not correct. Let me check. Supposed to add the public key in the Galera server, which we haven't done for these two nodes. So that's why we are getting an error. So I'm going to do that right now. Let's copy the public IP address and then disconnect this one and copy the port. And now go back and add the public key. Now let's check whether the Galera Manager can able to access the node 2. Yep. So now let's deploy. So while it's doing that, we need to go back and then add the the public key into the node 3 as well. Let's disconnect the previous one, log into the MySQL node 3, and I'm gonna add this key on the 3. Yeah, so now that we have added added the public key on the node 3 as well, let's go back and then see the status. So it's still going on. It's going to take maybe a couple of minutes. I'm going to pause, and then also I'm going to complete the setup on the node 3 as well, and then I'll come back. Now the node 2 is done. I'm gonna do the node 3 as well. I'm gonna copy the node 3 private IP and then check access status. Yeah, since we already added the public key, now everything is good. Let's go ahead and deploy it. Now we have the entire MySQL cluster ready. As you see, like we set up the cluster and then we added 3 nodes. Now it's time to do the data replication test. So I have all these 3 server here, right? I logged in, and then we need to do the replication test, right? So as you see, we have the IP. We access the servers through using the public IP address. Yeah. So now we need to log into the SQL and perform the replication test. How do we do that? As soon as I logged in into the server, let's execute the MySQL, and then once we do that, then we will be on the MariaDB console. Let me do that for all these 3 server. Now I'm on the MariaDB console in each in all these 3 server, right? So let's check the how many database in there. So databases, yeah. So right now I see like 4 database, right? And similarly, I'm going to check the other nodes as well. So in all these 3 nodes, we have only 4 database exists, right? So what I'm going to do, I'm going to create the new database, right? As you see, like all these 3 just has only 4 database, right? So what I'm going to do, I'm going to create the database here. Test, let's do the test DB, yeah. So now if I do the show database, you see like we have a 5 database available, right? As soon as I create, and then the new database also created. But in here, right, I'm gonna just execute the show database and see whether the test DB that we created on the node 1 is replicated on the node 2, right? Let's check it out. Yep. So now we have the test database replicated on the node 2 as well. And I'm going to do the same thing here. You see, we have the test DB available on the node 3 as well. So which means the replication happening here as well, right? So what I'm going to do, I'm going to do the one more test. I'm going to create the database on the node 3. Create database demo DB, right? Sorry, there was some spelling mistake. Okay, so now we have the new database created on node 3. I'm gonna execute the show database. Now we see we have 6 databases available. Yep. So again, I'm gonna execute the show database here. Now we have a 6, right? So now what I'm gonna do, I'm gonna drop the one of the database that we created earlier, which is test DB, right? So drop database test DB. Yeah. So now the test DB has been dropped. Now check how many databases exist. Now we have only 5. Earlier we had a 6, and since we removed the 1, and we have only 5, right? And let's check it on the node 2. Now you see the database that we dropped on the node 3, which is testDB, it's not shown here, which means the data is replicated. Now we're gonna check the node 1. So as soon as we execute the show database, we should have 5 database, but the test DB should be removed, and then the demo DB should be available, right? Let's execute the show database. Yep. If you look at this, we have the demo DB is available, and then test DB has been removed. So which means the data replication happening among all these 3 servers. No matter where you are inserting the data, it will be replicated across all this node. Now we are done with the replication, basic replication test. I would like to do the one more replication test by creating the table and then inserting certain data, right? Let's do that. So I have 3 console, MySQL console ready. So we have the database, demo database is already created. Yeah, so I'm gonna create the table in that the demo table. So sorry, it's demo DB. Okay, demo DB. Now we're using the demo DB database. Let me create the table. Now that we created the table as well, so let me execute the same command here as well. DB demo DB. Yeah, so now we see one table which is user, right? And if you do the query, it just returns the empty set because we don't have any data. Now I'm going to insert the um, some sample data. So I have 3 records. So I have Yogesh, Uma, Mahesh, and Ashoka. Yeah, these guys, my friends. I worked with them on my first MNC company called Fat Pipe. So, these are the guys that I worked with. Hey Yogesh, hi Uma, hi Ashok. So, okay, let's insert the record into the database. So now I have inserted the record, one of the record, the record in the third node. Now we're gonna see whether this record is duplicated on the node 2, right? So, sorry. What is the issue here? Select start from users. Yep. So we have the data replicator in the node 1 as well. So I'm going to execute the other record in the node 1. Now I'm going to test the record existence on the node 3. Yep, we get 2, and I'm going to execute one more record. Insert command on the node 2. Now it's executed. Let me go and check it here. Yep. So now check the node 1. Yep. All these 3 nodes have been replicated. As you see, like I insert the query, I execute the query, insert query in 3 different machines, but all the record has been replicated among all the servers. So which means replication working fine. Now we done with the replication test. Now it's time to create the database and then respective permission for the application to access the database, right? So if you look at this screen, so I have a create statement for creating the database called Java EEE, and then I'm creating the user and granting all the permission to the permission on this database to this user. But one thing, if you notice though, I am granting the permission only from the private IP, right? So this user, Java EE user, should be come from this particular private IP address. If somebody trying to access the database using this username and password from the public internet, they cannot be they will not be allowed to access the database, right? So the reason why, because I don't want anybody to access the database from the internet, but only from the internal network. That's why I am granting the user on the specific IP, private IP address, right? So let's go ahead and create this database on the node, SQL node. So I have this command ready. I'm going to execute this in here. Yeah, and then granting the permission, and then I'm flashing the privilege table. Now it should be available. It should be available in the other database, other node as well. Yep, it is available. So the next step would be to configure the load balancer with all the nodes. Now, so we are on the Hetzner Cloud dashboard, right? We have the load balancer that we created for distributing the request to among the SQL node, right? But we haven't configured it, right? Because if you see, it does not have any target. So what I'm going to do, I'm going to go inside and then add all the nodes that we created for MySQL cluster, right? So how do I do that? Just go inside the load balancer and then click on the target. Yeah. And when you click on the add target, we have option to add the cloud server. And just click on the cloud server. Then we have this option, right? Node 1. Okay, I'm adding this one in the private, and third one using the private IP. So I've added these two servers. So now you see, right, when the request comes here to this SQL load balancer, the request will be distributed to these two servers. But I'm just wondering why this second server is not available. Let me the blocking action is currently running on the server. Okay. Okay, not sure why we are unable to add. It says like a blocking action is currently running on the server. Okay. Okay, so there was some glitch. So as soon as I restarted the server, the error went off. So now I'm adding the one more server to the cluster. I'm sorry, to the load balancer. So as you see, now I can able to select this SQL node with the private IP, yeah, under the load balancer. Now this load balancer has 3 nodes, yeah. So all these 3 nodes. So when the request comes in, the request will be distributed among these 3 nodes. Since we have the replication set up, so no matter where the request goes to, the data will be replicated in all the nodes. So and the other thing is we have created the user using the specific private IP, right? Not a specific, but the group of IP from the private network can able to access it, right? This will work because if you look at this, and I have the private IP address attached to the load balancer. When the request comes in, the request will be sent through the private IP to the database. In that way, we can able to restrict the public access to the database. Rather, any request that needs to reach the database has to come through the load balancer, and then load balancer would talk to the node using the private IP address. So that's why I have created the user with a specific range of private IP. Yeah. So now we have set up the load balancer and then added the 3 nodes. Now it's a time to test and see whether the requests are distributed to all the servers and the replication happening by writing a simple Java application and then use the load balancer and it is. Now that we created the database, let's go ahead and create the table inside the database. So I have the simple table that I'm planning to create, which is called users. I'm just going to copy the script and then going back to the MySQL console, and let's use the database that we created. And create the, let's make sure there's nothing in there. Let's start from store tables, nothing in there. So I'm going to create the table called users. Now we have one table called users. Then let's go ahead and test the application. So I have the simple Java application that I created for our demo purpose. So if you look at this, I am using the load balancer, SQL load balancer in the application to store the data and receive the data, right? So so let's start the application and see whether it is connecting to the database server through the load balancer. So the application started, and it's trying to connect to the database through the load balancer, but it seems like it's getting delayed due to some reason. Let's see what happens. Okay, now we got some error. Let's go and look at, so it says application failure, and then it says connection timed out, and then the communication failure. So which means the Java application unable to connect to the SQL server. The reason I'm saying it's unable to connect because this is the only external URL the application is talking to. So should be some issue with the load balancer. Let's go back and check it out. So we have the SQL load balancer host name here, and we have its proxy. Let's try to remove the proxy and make the entry as DNS only. Probably this should fix an issue. Let's go ahead and then start the application again and see whether the application connecting to the database without any error. It's trying to connect. Let's wait for a few more seconds. Again, we're getting an error. Same communication failure. Okay. It was just the DNS propagation error. As soon as I flushed my local DNS, it started working. Okay, let's try to run the application now. So I haven't made any changes. It's still the DNS. I kept this as a DNS only, so I haven't made any changes. It's just the cache issue. Now if you look at right, I mean the application started successfully. So from the application we could be able to talk to SQL load balancer, and now we should try to test the application by creating a couple of records. So now I have my application running locally with this endpoint. So what I'm going to do, I'm going to create some sample record. So I'm just going to send it. Now the record has been created. Yeah. So I have the endpoint to get all the user information. I'm just going to hit it. Now I see the record that exists in the database, the record that we just pushed into database through the REST API, right? So I'm going to do one more push. Is run mass, and I'm going to hit it. Now the record has been created. I'm going to go back to the get endpoint and see whether the record it's been pulled. So yeah, now you see, right? So we have the another record is being pulled from the database. Now we need to check whether this record exists in the database, right? So let's go ahead and do the select query. Users, yep. So now we could able to see the record in the database, right? So what I'm going to do, I'm going to do one more testing here. So basically I'm going to execute this last, I mean this insert statement in the backend and see whether this is being pulled out there. So it's supposed to pull all this record as well. I'm just trying to do the different type of testing. Now we have the Ashok Mela record has been created. Now let's go and check it. Now we see this record is being pulled. So now that we have tested the application, the Java application, which are actually sending the data user details to the database through the post method, and then it also retrieves the data from the same database, right? So which means our load balancer distributing the request to the respective SQL nodes. Yeah. So now we done with the basic testing, right? So there is one more testing that I wanted to perform right now. That is with respect to accessing the SQL node through the public IP, right? So if you look at this one, right? So we have the multiple node, and we have the public IP is available, right, for each and every node. Since we created the user only allow from the specific private IP, which is this, I'm going to test whether the database allowing the user from the public internet, right? So I'm going to copy this, and I'm going to use this in here in the data source URL, yeah, and see whether we are allowed to access the database. It shouldn't be, because we create the user and permission only to allow the request which is coming from the private IP, right, not from the public IP, right? So, but we have all the data replicated. Let's try that and see whether the request is being allowed or not. Okay, so I put the IP address in here, and then I'm going to start it again and see whether we are getting an error, or yep. So we are getting an error. And what is an error? So it says like host, my local host is not allowed to access the MariaDB. Yep. So the application working as expected, right? So when we use the non-SQL load balancer IP, we are being denied, right? So okay, so at least this looks good, and then let's go to the. All right, now we successfully set up the MySQL cluster for high availability. We gone through various steps in configuration, like setting up the the load balancer, and creating the host names, and creation of Linux server, setting up the Galera Manager, and creating the SQL node. And then we have also tested the application using demo Spring Boot application, and then we covered all the replication test. So there are a lot of moving part, and I hope you guys enjoyed it. And then now you have the some idea how to set up the SQL cluster with high availability within less money, right? That is most important. So the reason why I created, because this video, because we need to set up the infrastructure in the cost effective manner, right? So I hope you guys have that knowledge how to set up the cluster with less than $25. And again, I have a few things that I want to discuss, right? So is it production ready? I would say yes and no. For a simple application, we can still make use of the infrastructure that we set up today, right? It is no, or if it is a mission critical application. And if the application requires a lot of security, and then need to deal with a lot of concurrency and a huge amount of load, then it is not a right setup for handling from those perspective, right? There are a lot of area where the current setup, whatever that we've implemented, can be improved. For example, for faster response time, and then system performance and scalability, we can do the horizontal scaling and vertical scaling, and then backup solution, adding additional storage to the SQL node and things like that, right? If you're really interested in exploring in this area, please let me know. I can create a separate video and then keep you guys posted. Share your comment in the video, or send out an email to our email address, info@javaee.net. And then obviously we have a nice community out there for Galera, right? So you can reach out to the Galera community just in case if you have a clarification. All right. Again, thank you so much. Finally, we did it, right? And thank you so much for watching the video. Please don't forget to like, comment, and subscribe, and also forward this video to your friends to let them also get benefited, right? I have included the Hetzner reference URL in this video. So using that, you can able to sign up and then get the €20 free credit to set up the similar, SQL cluster on your own. And thank you so much once again, and happy learning.